When does speed matter? Well, certainly when you're a racehorse or a jockey, because if you can get around the track faster than the competition, you win the race and you get the prize money. Well, it's really the same in business. If you can get the job done faster than the competition, you win the deal and you get the money. So speed is not only important in horse racing, it's also important in business computing. And speed in computing these days means a 486 PC. How fast is the 486 and is it worth betting on? We'll answer those questions and more as we look at the 486 option on this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by DataStorm Technologies, setting the standard in PC communications through the development of award-winning software such as Procom Plus, combining power, ease of use, and affordability to become the best-selling communication software in the world. And by PC Connection and Mac Connection, mail-order software and hardware peripherals for the PC and the Macintosh. And by Byte Magazine and BIX, the Byte Information Exchange.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and with me this week is John Wharton, a columnist for the trade publication Microprocessor Report. Now, we're dealing with microprocessors here, John. We have two identical computer setups, except I have a 386 CPU over here, you have a 486 CPU over here, and I want to see what difference that really makes. We have an AutoCAD demo up here, so when I say ready, get, set, go, we're going to start this demo at the same time and see what happens. Ready, get, set, go. Well, it's pretty clear your 486 beat mine on that first slide. Let's wait to see it draw one more slide and see what the difference is. Well, boom. I mean, the 486 is done. This hasn't even started yet.
That's right.
All right. Who needs the power of a 486, John?
Who needs the power? Computer-aided design applications like this, database servers, virtual reality systems, multimedia authoring. These are examples of power user applications where people just are never happy with the performance they have.
All right. We're all not power users. I mean, I'm the average guy running a business using spreadsheets, word processors. For me, does the 486 matter?
The rest of us can benefit from the 486 speed as well. If you're doing a word processing program, it might be nice to have the spell checking go on in the background so you don't have to stop and do that later. If you're in the midst of a spreadsheet, it would be good if your computer might call in automatically and pick up electronic mail from a server of some sort.
All right, well, as John mentioned, one power-hungry application is a database server on a network. And as we saw with our little AutoCAD demo here, a 486 CPU can make a big difference. We're going to see what that difference means now on an SQL server.
When this organization was originally conceived in 1983, it would have taken a mainframe to do what we're doing now on the 486s.
Matt Costello is systems administrator at the Center for Money and Politics, a research organization in Washington whose clients are political candidates and news organizations. They maintain a 3-gigabyte database of people who give money to federal candidates. They just switched to ALR 486 computers, which run under OS/2 and are connected to a Gupta SQL server.
Well, the 486 in our implementation has allowed us to expand the database back a number of years, so that we've almost doubled it in size since going to a 486. And the processing speed has, remained about the same, or, improved a little bit.
With the power of the 486, Costello can access the SQL database using plain English language queries. The server finds the data and then determines the best path for sending it back to the client terminals. The power and the speed of the 486 means getting clients' answers in minutes rather than days.
I did a study for a client, a vote correlation study, and going back to 1985, and she did it manually using paper printouts from the FEC going back earlier than that, and it took me 10 or 15 minutes to complete on the computer, and it took her 3 days to do the earlier data manually.
For the Computer Chronicles, I'm Maria Gabriel.
Sometimes having a 486 CPU can be like having a Porsche on a crowded freeway. The car or the chip can only go as fast as the supporting system architecture. Here to show us the importance of what you put around your 486 is Charlie Sauer of Dell Computer, and back with us John Wharton of Microprocessor Report. John, we've seen a tremendous increase in processor speed over the last 10 years or so. What's the underlying technology that's allowed us to get such faster chips, faster clock speed, faster CPUs?
It's really a combination of factors. The basic clock frequency has gone up by about a factor of 10 in the last 10 years. The number of clock cycles required to complete each instruction has fallen by a factor of 5 on average. And you have more powerful instructions now that can process 32 bits of data instead of 8 or 16 bits. All told, it's about a factor of 50 overall improvement versus the processors of 10 years ago.
Right, but how about the point I was just making before? What's going on around that processor, though? The I/O, the bus problem is still pretty slow, isn't it?
That is the problem. Since the days of the AT, the bus really hasn't changed that much. So you may have some slight improvement, but you're still reaching a bottleneck. It's a little bit, one analogy might be the airline industry. If airplanes were 50 times faster than they used to be, you would be able to fly from Los Angeles to New York in maybe 10 minutes. That wouldn't be quite as advantageous, though, if it still took an hour for you to get your luggage off the plane at the other end.
That's the bus jam up right there.
The bus is like the conveyor belt that brings the luggage on and off the plane.
All right, well, let's see how we solve that over here at Dell. First of all, describe the hardware setup you've got here, Charlie.
Okay, these are both 50 megahertz 486 ESA machines. They're identical except for the graphics subsystem.
Okay, and we do have different displays here, which is part of the
displays are different because of the graphics subsystem. The one on the right has higher resolution, so we have a larger screen.
Okay, but inside two identical CPUs, 50 megahertz 486.
Inside they're identical CPUs.
All right, now you're focusing on the graphics part of the speed problem here, and tell us about that and show us what's going on with these boards here.
Okay, in a traditional PC, the processor connects to the memory. This is an add-in processor card. Here's the processor. This connects to the memory bus and on out to the I/O bus. The graphics is way out on the I/O bus, and the processor sends commands out to the I/O bus to get graphics done. And it's a long path, it's a narrow path, it's a bottleneck, both for the program and for the programmer.
And this is what we would be seeing in the machine over here, is that correct?
That's what we're seeing in the machine on
What's
the
the
left.
difference in that board?
This has processor direct graphics. Instead of going out to the I/O bus for graphics, we go straight over to this video memory right here, and this is a large amount of video memory to give us high resolution and a large number of colors, and then on out to the monitor directly.
And that's the board that's in the machine
That's the
next
board
to you.
that's in the
Now
machine
show
on
us
the
what
right.
that means to me if I'm running an application.
Okay, I'm going to bring up an Excel spreadsheet on both machines.
Okay, same spreadsheet,
Same spreadsheet.
and what are you going to ask it to do?
It's going to merge two spreadsheets and then graph numbers from each of those spreadsheets. The one on the left actually started earlier, but the one on the right will finish earlier. And they'll both show the times at the end when they're done.
So we're merging two spreadsheets and then graphing the results
That's correct.
of the composite spreadsheet. They're both doing the same thing.
They're both-
What should we expect here in terms of performance difference?
The right one will be about twice as fast.
Okay, now the right one's already into the graphics, and this one is still working on the spreadsheet. We can see that already.
That's correct.
This hasn't even begun getting to the graphics part of this task.
The graphics will actually look about the same speed when the graphics are being done. What really is being faster is showing the spreadsheet on the screen. That's what's really catching up the right one ahead
All
of
right,
it.
so we're done now over on the right, and it took how long to say?
29 seconds.
And that job is complete, and we're just really gotten into the graphics part of the problem over here. Again, same CPU, same clock speed, everything's same, except the difference in how you're processing the graphics information.
Everything's the same but the graphics.
Now, why did this guy start again there?
Oh, I forgot to hit the escape key to
Just
stop
doing it again?
It's going to keep
It's going to
going.
do it twice in the time it takes to
gonna
get
do
it
it
done.
twice in the time.
Probably. Well, as a matter of fact, it looks like it's caught up, sort of lapping the computer over here.
Yeah, it is going to lap the one over there.
Okay, so the one on the left should be done momentarily. And it is, and it took, what, 1 minute, 7 seconds compared to 30 seconds
29
over there.
seconds over there.
So just by making that one improvement in the graphics, you were able to double the performance over there.
And so this one's done too
Yeah.
now.
All right, now you have an animation demonstration. If you can
Right.
get that loaded up for us too, so we can see what the difference really is there also. While he's doing that, John, it seems to me we're tugging in two different directions. The more we integrate, the more we shove all that stuff onto that one place, we're moving in the opposite direction of another goal, which is modularity, easy upgradability, and so on, aren't we?
Yes and no. We are putting more of the power into the processor, so there's less need of boards in the outside world. What I expect to happen in the future is that the upgrades will tend to take place on the processor board itself. You may replace chips. You may have a variety of different chips of different performance ratings. The reason you would still need add-in boards would be to customize your system for some special application, changing from a Ethernet controller to a fiber optic network, for instance.
Yeah, while Charlie finishes getting the animation demo up there, explain, we're talking really about the 486 primarily on this show, and what makes the 486 the 486? How is it different from the 386, Jeff?
Again, it's several different factors. The 386 had a budget of about 350,000 transistors to work with. The 486 has 1.2 million. That's 4 times as many.
Okay.
What that allows is a large amount of memory to be put on board the processor.
Yeah.
It allows certain functional units to be replicated. Instead of having to compute addresses one step at a time, you can compute the addresses all at once.
Yeah.
One thing the 486 does is a lot of speculative execution. It may not know what has to come next, but it does it anyway, just in case that has to be done.
Yeah. Okay, Charlie, how are we doing over here?
Okay, the animation's going on the left, and it's going pretty well. The animation on the right's about to start, and you'll see it's about twice as fast. It's just zooming along.
Right, right. And once again, everything's the same except
Everything's the same
you're
except for
treating
the graphics
over there.
And but this one's able to go twice as fast as a result of the graphics difference.
Now, are you selling the board? Is this simply a new Dell computer that you're selling? What's the product?
These systems are designed to have replaceable processor cards, and so right now we're selling the machine with this card and other cards. We're not yet selling this card. This is a prototype, but in the spring we'll be offering a machine with this card as well.
Yeah, well, these little Roadrunner here guys certainly show us the difference. One last question, John, what's next? I know we're hearing about the P5 now. I mean, how far can you push the speed question?
Well, people tend to look just one generation ahead at a time.
Yeah.
The P5 is likely to be announced sometime later this year. What I would expect to see in that is somewhere between 3 and 4 million transistors in the budget. What that allows is perhaps twice as large a cache, perhaps reducing the number of cycles per instruction closer to 1 on average.
Yeah.
It might even be possible in the P5 to execute several instructions in parallel. Overall improving the performance by another factor of 4, perhaps.
Well, hopefully you find out more about that soon. Gentlemen, thank you very much. All right, suppose you love the idea of a 50 megahertz 486, but you are also a laptop freak. Is there a machine for you? Yes.
Virtual reality is one of those applications that can never get enough speed. So when Tom Kuhl of the Sense8 Corporation goes around showing off his new virtual reality product called World Toolkit, he needs all the power he can get.
The 486 50 megahertz chip has really made this technology practical. Prior to the 486 50 megahertz processor, the frame rate, or the number of times that the computer can update the scene, just really wasn't sufficient. We need about 12 frames per second. And the 486 50 megahertz processor has made that become a reality.
This Dolch computer is currently the only 50 megahertz 486 portable, but at 18 pounds, it's not quite a laptop, and it's not the kind of computer Tom Kuhl would use on an airplane.
It is meant to be operated when he arrives, wherever he'll go, off-site, to have all the power. Therefore, these kind of machines are not battery operated, have no need for that, and therefore there was no need to maximize battery life. We have maximized performance.
The Dolch 48650E does pack performance with a 120 megabyte hard drive, VGA display, and 4 expansion slots. But such power has a price, in this case, about $9,000. For the Computer Chronicles, I'm Maria Gabriel.
Okay, nothing is fast enough for you. You bought your new 486 computer, but you still want more. Well, thanks to those new little vacancy signs inside your computer, you can now upgrade to get even more speed. Here to show us how are Dennis Carter of Intel, and also with us Bob Kutnick of Amclay Systems. All right, Dennis, let me ask you first of all, we're doing the show about the 486. Some people are still upgrading to the 386. Andrew Grove, CEO of Intel, spoke a couple of weeks ago, and he said, well, the 386, that's for under $1,000 entry-level home computers. The 486 is for small businesses, but it's really all the P5, the new processor that's coming, that's the serious chip. Is this all history already, 386 and 486?
Well, we're definitely seeing a movement of 486 becoming the standard in business applications. And there is no question that 386s are becoming ever increasingly cheaper and moving downscale.
Right.
The P5 is something that Intel will be introducing later this year, and so isn't a player in that yet. This is kind of a normal phenomenon that you see of the spiral, where Intel comes out with a new processor that brings ever more power, and the software guys all race to use that, and pretty soon you find that the power isn't quite enough to do everything the software guys want to do. And so the cycle goes on.
All right, Bob, that's what I want to talk to you about. The cycle goes on. Everybody says, geez, I don't want to buy a machine because tomorrow there'll be something better and tomorrow will be something. So you make an investment in hardware and you don't want to junk it all to buy a new 486 machine or to up your clock speed or whatever. You guys at Amclea are focusing on the upgradability problem, I take it. And tell me what your approach is here in the box you have in front of us.
We've actually focused on modular upgradability, which not only includes upgrading the processor, but even includes upgrading such things as drives. We've created something called a power drive pack, and what that does is by simply pushing a button, the whole set of drives, power supply, and everything comes out of the machine.
Now, why would you want to do that?
It allows you to upgrade drives. It also has a feature if something goes wrong, for example, with the electronics in a machine, and this is now where all your information is stored at the company, you can easily move it to another machine in a matter of minutes versus waiting for a service attendant to come hours down the road and move drives in and out and do those things.
Okay, now Bob, you also have an innovative approach to BIOS update. How are you handling that with the Amclea machine?
Well, a long time ago we had a situation where if BIOS ever changed, what that required was changing one of these chips in here or both of those chips. What we've done is we've gone to a part that's called a flash part, which is an electronically programmable part. That part allows us to upgrade the BIOS using a diskette. So what happens is when you want to upgrade your BIOS, you stick in a floppy disk into the machine, you actually push a button so that you don't run into any viruses or anything like that, and that actually allows you to reload the BIOS right into the machine.
So you don't have to risk pulling the chip out and squeezing another one in.
Exactly, no bent pins, no hurt fingers, it's all software.
Okay, now finally, I've got a 386. Let's say this has a 386 board in it right now.
Correct. This is now a 386 33 or 25 machine. I'm sorry.
And I want a 486 machine. What do I do with this Amclea?
That's actually done as simple as pulling the card out of the machine and then replacing the card within the machine by simply sliding this card into the machine, pushing down. We've now installed a 486, and this is now a full-speed 486 33 machine. And this card can actually be done with 486 50s. It can be done with 486 SXs. Gives you the whole realm. And actually even allows us to upgrade within this card itself.
And now, how hard is it to get that power disk drive unit back into this?
Power drive pack is very simple. We actually just pick it up, line up the tabs in the back, push it down.
Wow, that's pretty good. All right, Dennis, let's turn to you. And we've all seen these great commercials with this vacancy slot lighting up inside these computers. And we've been trying to figure out what we're going to put in there. And I guess you're coming out now with one of the first products that you can actually use to upgrade your 486 PC, right?
That's correct. We've looked at the problem from the CPU point of view. And one thing that we've heard back from the community in upgrades is that what people would really like is some kind of midlife kicker, so that as their systems spiral up this ever-increasing curve of wanting more power to run the software, that during somewhere in the midlife of the machine, they can kind of upgrade it to bring it back up to the speed of the new machines that they would be comparable to that. So we've used a speed doubling technique, and we have a product that we will be introducing in the next couple of months that we call Overdrive, that fits in that socket that you described with the vacancy signs pointing
Okay,
out.
and what does Overdrive do for me?
Well, Overdrive is a 486. It fits in the empty socket, and it basically allows your CPU to run twice as fast as it did before.
Okay, twice as fast meaning from what to what?
Well, if you had a 20 megahertz system, for example, an Overdrive processor runs at 40 megahertz internally, yet still maintains the 20 megahertz external signal. So your system basically gets twice the CPU performance.
I mean, even if I'm at 33, say,
you then would have an Overdrive that went at 66.
Okay, can you show us how this would actually work here? Can we do something and then upgrade the machine and then do the same thing again?
Correct. We have a demo here. Now, you double the CPU performance, and we tried to put together a demonstration that would show you how you normally use a machine in a business application, so you could see what kind of performance you would get, what you would actually see. So we're going to run you through this application. The application is mimicking a situation where you would be writing a report.
Okay.
And so we take you into Windows, and we start with WinWord. We're scrolling through a report that presumably you've already written. We're going out to a spreadsheet, getting some data, affixing it to the report.
Okay. So we're in the usual sort of presentation, word processor, spreadsheet, slides or whatever?
Right.
Okay.
You can see here we're generating some graphs, some charts that we'll put into the report from the Excel data. When we get that done, we'll go through the always word processing stage, where, excuse me, the spell check stage, where you go through and make sure all your spelling is correct.
Right.
And again, what we're trying to show is an application that does both disk accesses as well as the CPU.
So this thing is running on its own, but I mean, this is a real-world application.
This is a real-world application.
You just sort of macroed it, and it's running through all these steps on
Exactly.
its own. So we can see how long it takes for it to do this right now.
That's correct.
In its current mode, which is what? This is 486, what?
This is a 48620.
Okay, 48620.
This is a 46SX20.
Got it.
And we'll measure the elapsed time. We'll then let you do the upgrade,
Okay.
and we'll measure the elapsed time again, and you can see what kind of performance gain you would get. We're now going through a character recognition program. It's OmniPage, and what this program is doing is we're assuming that you want to scan in a document to affix to your report, and when you do that, you scan it in graphics format.
Right.
You then need to go through and do character recognition to turn it into text format so that you can put it back in the word processor. This turns out to be a fairly CPU-intensive part of the application. You can see the character recognition actually going through in blocks. And after we've done the upgrade, you'll be able to see that visibly happen much faster.
Okay, so we're cranking through a fair amount of work here, and it's
Correct.
done?
And we're done. And you
It
see the
took us
elapsed time.
106 seconds, let's say, to
106
do all that
seconds.
work.
We'll shut down Windows. There we go.
Okay. So you're going to show me how to do this overdrive upgrade?
Correct.
Thank you for shutting the machine off.
Yes. Now, if you could ground yourself here where we
Okay.
do the upgrade.
All right, so this
Yes.
is the chip that's going to double my
Correct.
speed. And just stick it in?
Just stick it in. It has a key pin in it
I
so
see
that
it,
the
yeah.
orientation
It just sort of falls right in there.
falls right in it.
Okay.
Very
Done.
good. That's it.
I just upgraded the machine.
You've just upgraded the machine. We'll turn back on the system.
And we're going to do the same thing again.
We'll do the same thing again.
And I should be running at 40 megahertz.
Correct.
Okay.
Now, as the machine comes up, we have to go back through the startup phase as it
Okay.
loads in the window.
Well, while doing, let me ask you. I mean, you said this was a zero insertion force system.
Socket, yes.
Yeah, because I sort of dropped it in there. I didn't have to squeeze those pins in.
Correct. There are several sockets that make the insertion process very simple. This one is called a zero insertion force socket, as we've said,
Yeah.
and it is incredibly simple to put in and also to extract.
That's one. So I just lift that lever and pull it out if I want to.
Correct.
Okay. So we're pulling up the same demo now?
That's correct. And we'll go through it one more time.
And now theoretically, what should happen here in terms of speed performance?
Theoretically, you'll see an improvement of something between 50 and 70%. The CPU-intensive part will be running twice as fast. The part that accesses disks or whatever will slow that down
Okay.
on average.
All right, can we run this?
Certainly. So we push F2
So
again.
we're gonna do
and
the same
we're
demo.
back off again.
Okay, and it'll run the same bit and it'll clock itself and tell us.
Correct.
Tell us what's
The
going on.
elapsed
Let
time.
me ask you, while we're waiting for this to run through, I mean, we've seen before, I mean, CAD is a really power-hungry, speed-hungry
Yes.
application, SQL servers and so on. We're just doing kind of routine stuff here, spreadsheet, word processor. So, I mean, is that an important arena in which I should care about this speed? Does it matter enough to
Oh,
me?
it certainly is because, first of all, the graphics, which has been one of the things you've talked about in the show, the graphics always take more power from the CPU, steal CPU cycles to do them, and so the more powerful the CPU is, the faster the perceived graphics are. When you open several windows, you're stealing a lot of
That's
CPU
for sure,
cycles.
yeah.
So there actually are a lot of things that you think of as mundane applications that really are pretty power hungry.
Especially working in this environment.
Correct. Now you can see we're in the application.
already into
here.
the scan
yeah,
part.
we're in the scan part. So it's going much faster, and you can visibly see the scans.
Okay, so we were 106 seconds before.
Correct.
About, what, a minute 40 or something like that, minute 46. And we're guessing this should take, what, about half as much time?
Yeah, it'll probably take around 60 or 65 seconds.
Let's see, we're getting to the, here
65.
we are. Okay, so 106, 65, that's pretty good savings.
Yeah, that's about 60, 65%.
Yeah, and when do you
performance
expect to
improvement.
have the overdrive?
We'll be announcing this product within the next couple of months.
Okay, you've helped us appreciate the power of speed and upgradability. Thanks, gentlemen. That's our show on the 486. Dennis, I hope we'll be back to do a P5 or 586 show at some point. Stay tuned now for this week's computer news on Random Access.
In the random access file this week, March 6th has come and gone, and one research firm says 15% of all end users were affected by the Michelangelo virus. Most users fortunately located and zapped the virus before it did any harm. Michelangelo was widely distributed and found its way onto leading-edge PCs, Intel's Landspool print server utility, and several other commercial products. There were reports of the virus on PCs on Capitol Hill, though not on the mainframe which serves Congress. There were even reports of Michelangelo as far away as Western Australia. Intel has just announced a new version of its 486 chip called the 486DX2. This next-generation chip incorporates the speed doubler technology used in the overdrive add-in chip. Several PC vendors, including Compaq, AT&T, NCR, Gateway, and Xeos, have already announced new models that will use the 486DX2. Digital Equipment Corporation is touting its next-generation CPU called the Alpha chip. It's a 64-bit RISC-based processor that runs at 150 megahertz. Well, Hyundai says it has become the first PC maker to offer a lifetime warranty on its computers. The warranty covers the motherboard, video card, floppy drive, and keyboard. Toshiba has announced further price cuts on its notebook computers. The price on the popular 2200 SX is being cut 25%, down to $29.99 for the 40-megabyte version. The best-selling software product for the PC last week was Stacker. TaxCut dropped to number 4 and TurboTax to number 5. No other surprises in the rest of the top 10. Finally, the Hungarian National Bank reports that it found a virus in its computer system in Budapest. But this virus, unlike the deadly Michelangelo, simply caused the bank's computers to start playing music. There was no loss in data. That's it for this week's Computer Chronicles. I'm Maria Gabriel.
Computer Chronicles is made possible in part by Datastorm Technologies, setting the standard in PC communications through the development of award-winning software such as Procom Plus, combining power, ease of use, and affordability to become the best-selling communication software in the world. And by PC Connection and Mac Connection, mail-order software and hardware peripherals for the PC and the Macintosh. And by Byte Magazine and Bix, the Byte Information Exchange.
Video cassette copies of this program are available. Computer Chronicles also publishes a companion newsletter containing details on products demonstrated, plus background information on program topics. To order a video cassette or a subscription to the newsletter, call 1-800-366-9484 or write Computer Chronicles. Please specify program subject for tapes.